Thank you, sir. Welcome to the final course of the day. I imagine you're all a little fried, probably brains are crammed full of all kinds of cool stuff. This is a bit more of an intro course, so for those of you that actually already know this, you get to relax your brains and just enjoy a nice refresher. For those of you who are still learning new stuff, welcome too. I hopefully have a lot of great content for you, and hopefully you'll know a bit more about test-driven design and test more after we're done with this. And hopefully this works. No. Okay, we'll use my arrows. Oh, I know what I need to do. I need to do that. Nope, still not working. There we go. Bit of a story. Two stories, actually. First story is, we were out to sushi for lunch today, and one of my coworkers and friends was wearing this t-shirt. And I'm like, this is perfect for my talk. Can I take a picture of you? He graciously agreed, and so I now have his shirt on there, which is perfect. Second story. So I'm coming up on my second decade dealing with Perl now. I started in dial-up days. I got a cool dial-up account, and they gave me some space on their server. And I'm like, what do I do with this? So then I started looking at CGI and the languages that you could write it in. I was studying computer sci at UBSC at the time. And yeah, my options were pretty much C or Perl. I'm like, I'm learning C, let's do Perl. That's how it started, and it was all downhill from there. So that said, my testing career in Perl has been a little more lackluster. It wasn't near till about a decade thereafter where I'm started thinking, hey, maybe I should start testing my work. Turns out my work turned out a lot better, kind of a bit of a higher quality level of work I started producing when I started testing things for some reason. But yeah, I've also started working at an amazing company, Bluehost, owned by Endurance, where I had a web apps team, and we're also working on a lot of test-driven related ideas. We use TestMore quite a lot. We also do JavaScript, and so we've been doing lots of JavaScript type testing stuff too. So yeah, that's my background. That said, the moral of the story, don't be like me. Don't wait till half of your career in whatever language you're using to start testing. Do it now. And why? Couple reasons. Reduce human error. It doesn't matter if you're the most expert at manual testing in the world. It doesn't matter if every single little change you're going back between your code and running it. You're going to miss something. It's human nature. We have human biases. When you start running automated testing in addition to your manual testing, then you almost have like another safety net. It can certainly reduce that human error. Another cool thing about testing, it gives you a different perspective on your code. You come at it outside. So you're almost like acting like a consumer of your code, a customer, as opposed just to its creator. That can help you design your code better, either your interfaces or even just the internal stuff. How it all works together. You may get a different perspective and want to change things. And then all that can lead to structural improvements. You're fixing bugs, you're making optimizations, you're changing the way things work. You might be still keeping the same behavior overall, but under the hood, it's much more optimized, faster, better. And on top of that, when you're doing automated testing, you're building a suite of regression tests, which means when you start getting into feature development or you start making changes to your existing code, then you're going to have something that you could run again and again and again to make sure that it still integrates with everything else that you've already built. And when you've got a huge project that you've been working on for years, this is a lifesaver. And when you don't have it, you can feel it. Small caveat to this whole automated testing thing. Oh, wrong one. This is the right one. I need to use the down arrow more. You can't prove the absence of bugs. There's just no way to build an automated test suite that will ever test something perfectly 100%, because you don't know they're there. Usually what you're doing is looking for things to appear weird. So that's what it'll do, is help you reveal things. But it doesn't mean it doesn't mean that you'll be able to be 100% assured this is production ready. There's really never that guarantee. Let me go back up now. So, TDD, test-driven design. You might have also heard it's been called test-driven development. I prefer design. I'll talk about why here in a sec. Overall, the methodology is pretty simple. It's this constant cycle of building tests and building code. Building tests first. So you start over there on the left, move your way around, and then back again. And then it becomes this feedback cycle for you. Build your test. It'll fail. Then build your code. Then it'll work. Maybe you refactor your code. Maybe you refactor your tests. You just keep going and going and going and building. Here's a little bit more of a formal definition. So add a test. Run them all. Make sure that, of course, the new one will fail, which it should, because you haven't written code yet. Write some code for the test, obviously. Then run your tests again. Then refactor your code, especially if it doesn't work. And then rinse and repeat. And you'll keep doing this cycle over and over again. That, by the way, was directly pulled from Wikipedia, which is a decent resource, actually, to start getting into TDD. It's not a hard concept for devs. Just remember, test first.
You understand
Hard to do. Yes, self-discipline is a trick there. Yeah.
I've always found that one of my problems is I don't want to run all of the tests every time I add a new test. There's a lot of overhead a lot of times. So how do I add a single test? Do I have a separate file where I create the one test and then merge it back in?
I recommend getting modular with your tests. I'll actually talk a little bit more about testing architecture in a minute. And yes, then you're down to maybe even just a group of tests. And ultimately, if you want to isolate to one test, you can go further. Maybe you can comment out some of the subroutines that you're running, other subroutines you're running. I'll show you an example of, actually, I was doing just that a little while ago. And then another thing you can do is with your test runner. I'll tell you what a test runner is more, for those of you that know what a test runner is. Either you're building one or you have one. Hopefully, there are options there for you to isolate to your tests. Why do you want to do this? Why would you want to do test first? Well, it's still just testing. So all the same benefits with any testing you do, whether you build your automated testing after, before, any automated testing you do, you get those benefits. But testing first has a killer feature, and that's why I call it test-driven design. And that is, you're going to spend time thinking about your design, because you're going to be building a test for something that doesn't exist yet. And maybe it's just a subroutine. Maybe it's a whole module you're coming up with. Maybe it's a suite of modules that are all interconnected. But you're going to be sitting there thinking, okay, I'm writing this code, and I need to assert what this is returning. How in the world is that going to work in the first place? It's going to get you thinking, which is a very good thing to do anyway. A lot of people that have been in the industry in a particular language for a while, people that have been around, they'll start doing this whether they do test first or not. This kind of enforces it a little bit. So if you can get enough discipline to start doing your testing first, then you're also going to start designing first every time. You may still not be convinced about that, though. That is A-okay. The truth is, it is a methodology. There are many out there. You may have to do something because you work with a certain team, or you're working on your own, so you can pick your own thing, whatever you want. Either way is fine. However, if you also are interested in this test-driven methodology, I would also recommend you look into something that's a little bit more for the whole process. And I'm not going to talk about this too much here, but I wanted to mention it as someplace else to go. This is built on the concepts of being test-driven design, and that is behavioral-driven design. There's also domain-driven design that contributes to this as well. There's lots of DDs out there. So look into it. This goes further towards that whole it's a killer feature to do your design this way, idea. And so it's about breaking up your code into behaviors and getting acceptance criteria from those that are designing these ideas for you in behavior form. And then even afterwards during deployment, the whole thing, they talk about this whole process. So it's much more grand, much more team-oriented, not strictly about development. But there is development parts in it as well. And I even used a couple things that I kind of liked. You'll see that. Testing architecture. So this is where I was talking about a test runner. So in Perl, our core built-in test runner we get is called prove. So when you got Perl, run command line, type in prove, that's your test runner. That will actually run your test for you. There's still a bit more structure to it, but when you want to start testing things, prove is a great example. You can also write your own. Test harness. And to clarify, Perl has a test : harness. I'm not specifically talking about test : harness. I'm talking about the general idea of a test harness. I'll mention that in a minute, but the concept is this is the thing that actually pretty much does the work. The runner will run it, but it needs a test harness who pulls everything together and then spits it out so that the runner can display it for you on standard out. Your test framework. This is your library or libraries that you plan to use to build your test suite. We're going to be talking about test more, obviously. I'll mention a couple others related to Perl. Test modules. This is where a lot of you will start coming into play. This is your development. You're building these out. And this is also kind of towards his question about what if I don't want to run all the tests? That's fine. Be modular about your tests. Build them in separate files. .t files is something you'll see a lot in Perl. And that usually means it's a test file. But it's still Perl. And then test assertions. These are the things that you use inside of your test modules to make stuff happen. When we get into test more, I'm going to go into a pretty good amount of depth on the assertions it's providing. So here's another example of a test runner. This is actually a command that I normally use when I'm doing my testing on my solo stuff. At work, usually I add a couple more -i's because there's a few more libs I want to load in. But yeah, like I said, you're just running the test here. It's going to have a bunch of options. If you do like a man on prove, you'll get a ton of cool things. You can choose any sort of harness, whatever. You don't have to use prove to test Perl. You can use prove to test Ruby or C or anything. It's just about setting up your harness and then pointing to the tests. Your test harness. I mentioned before test : harness. This used to be the way that Perl did it. We've moved a little bit since then to something called tap harness. Test harness still exists for backwards compatibility, but it is naming, but it's functionality as well. And there's even some sort of dependency stuff where if you're using some older things with test harness, or if you're actually using test harness and like hacking into it and doing stuff with it, that you might have some issues, but hopefully you're not doing it anymore because they've been recommending to get away from test harness for quite some time now. This, by the way, is an example of a test runner that I built with test harness, just a manual one. So that script can also start running tests. Your test framework, once again, test more was one. Test simple, one that also is kind of part of the test more suite. Test simple actually just has a couple of assertions you already see in test more, so it's kind of great if you want to get into kind of a tutorial thing, but it's not going to be powerful enough for you to do your testing ultimately. You're going to want to go to test more or some other framework that gives you quite a variety of assertions. And you may not even want to be done with test more. I'll show a couple other things where you add more to the test more framework per se. Test unit and test BDD cucumber are two other ones. Does anyone recognize cucumber, not as in the vegetable? This is a Ruby thing, actually. So Ruby uses the name cucumber for some of its testing. And so actually some of the form and concepts in that particular module that is related to behavior-driven design is built into a more Perlish module. So that might be also one to look into as well for the BDD side stuff. You don't need to do it, though. Once again, you can still be test-driven, even behavior-driven, with test more. Your test modules. So here's a quick example of what a test module would look like. It's just Perl. You start with your standards. Then you're pulling in your module. I'll talk a little bit more about what you're doing there with the plan stuff. And I'll even talk more about some of the assertions. Actually, I can use this. So I just created a simple little subroutine. That is actually an assertion you get. This is where I'm testing it. Then I'm saying done. So if I were to run that through prove, then I would actually get some output. I'll show you a bunch of output. And then lastly, your assertions, which once again I mentioned before, are going to be, in the terms of test more, things like OK. And that's just one type, a very, very simple type.
So is it like, it's just an output that will be given if the assertion
Is true or false. Right.
It gives an OK or not OK.
It gives an OK or not OK. And then, but the cool part is that there's this whole complex process underneath where you're communicating your test between your test framework and your test harness to your test runner. And so I'll even be talking a little bit about that too, about how kind of that works. Right now, TAP, Test Anything Protocol. So I made up this nice little convoluted definition for you guys. A simple text-based output format for communicating the outcome of tests from test modules executed by a test harness. What? Yeah. Okay, easier definition. It's the glue. It's the glue between your framework and your harness. Technically, you could also see things in TAP directly, but this is pretty much the protocol that allows communication from that little OK assertion to go out through the test harness and then, out through the test framework, so test more, into your test harness, which is TAP harness, and then eventually gets wrapped around some other stuff and then is output to your screen from the runner. Couple cool things. It was made when I was 11, which is pretty awesome. It's been around a long time. It's now being used in many languages, not just Perl, even though it was originally invented for Perl. So you can use this, and what's cool is that if you have a multilingual environment then, you can use TAP as kind of your test output, and if you're doing some sort of crazy automated deployment.
I was just going to say, a talker just in ini.net was telling us that he had written a TAP producer in Bash. He calls it test more Bash or something like that. So,
Even in Bash,
yeah.
You can do testing.
And then he can use prove to run it.
And then you can use prove to run it, and you still get your tests. Or whatever runner supports TAP. Pretty cool. One of the reasons it can do that is because it has eBNF grammar. I'm a mild BNF geek. I like reading BNF for some reason. I think it's just cool. Studied it in school a while ago. In fact, we didn't have eBNF back then. It was just BNF. eBNF is more amazing. But the fact that it has a grammar that you can follow means that you can replicate it in any language, which is part of the reason why it's in a lot of languages. And you can even see the grammar right there at that module. And it's still evolving. Our current working version is on 13, and we're working on 14. We as a Perl community. So there's some TAP output for you. That's just a TAP output. That's not necessarily what your harness is going to give you. So this is okay. This is okay. And that's showing your tests 1 to 2. I'll actually note something interesting about that a little bit later. So note that it's after your tests. This is actually some actual output for something I'll be showing you later too. If things are not so good, you're going to see something more like this. Oh, this one was actually okay, that's good. But uh-oh, we've got a problem. And so you start getting a lot more detail about what's going on here. And it really kind of depends on what sort of assertion you're using, what sort of output you're going to get, and what you're trying to test, obviously. And then, of course, once again, your plan, it looks like you failed. if you're doing test-driven development, get used to this, because you're obviously going to be seeing failing tests more than you're going to be seeing the successful ones, because you're writing tests before you're writing your code. Now, what about the test harness? What is it spitting out to your runner? Well, it's very similar. You'll see right here on the OK side of things, there is the tap output from just the test framework. But you'll see also we were running a particular module, and then our plan, and then everything's great. And then it gives you this nice little summary, how long it took, ultimately pass. I think I can kind of scroll over a little bit, but I think that's all just more timing stuff, yeah. So lots of useful little statistics. And then we've got a failure, again. So once again, we're now running through our harness, this particular file. Everything was good here, but oh man, things were not so good here. Still see all of our tap. Now we see more information about something was returned that was bad. We failed. We get a bit more of a summary, which I had just too much here. Oh wait, and you can't see that unless I do that. And so, yeah, more statistical information. This is what you're going to see when you run proof and things aren't working. And the other one, of course, when things are great. Kind of a side note, CPAN modules. Everyone here know what a CPAN module is? Everyone, yeah? Anyone not know what a CPAN module is? A CPAN module, Perl module from CPAN. So CPAN is a central repository where we contribute our modules, and of course can get third-party modules that aren't in Perl core. And so when you go through and install one, we have a nifty little command line thing, CPAN, that you can just go through and install a module. So CPAN might assign your module, and it'll start downloading. When you're installing one, you see a ton of stuff going on your screen, because it'll say, oh, I'm configuring, I'm doing this, I'm doing this. It all depends on the module, of course, because the real complex ones are going to be lots of stuff. Simple ones, of course, would be like that, you're done. But then you're also usually, hopefully, seeing test output, where it's telling you that I am downloading this and I'm running the tests on your system and it's great, or it's not so good. And you're going to see your tap output. The things I was just showing you, that's what we're going to see, because we're still using test harness. We're still generally using, you don't have to necessarily use test more. There's lots of different ways to do this, but we're using tap when we're doing CPAN. So you're going to see all the stuff I've been showing you. Funny little story about this module. This is an Acme module. Acme is, by the way, a namespace on CPAN for the funny type of modules. The modules where they don't expect you to really use anything in production, do crazy stuff, just fun and games. That particular module has my name in it. That's because it actually is made from some other developer as a tribute to me. We were looking for this place to eat, and I was using Google Maps, and Google Maps was totally failing me. And so they came up with my nickname being the Travigator. And then my dear friend decided to actually make a module that just spits out random locations. It's not fully developed, but I thought it was kind of hilarious, so I had to put that in there. Now, what happens when your CPAN module install fails? Well, then if it fails, you just force install it, right? Absolutely. No problem. There it is. You can just do it simple. Notice, if. Big if. It may not work. No, you don't do this. It's probably a better idea to read what's going on in the testing and then try to resolve it if you can. Obviously, of course, for beginners, this becomes kind of an annoyance because you're going to be reading tons of things you don't quite get yet. Maybe you don't even understand the language yet. You're still trying to learn, but for some reason that darn module won't install. DBD MySQL, by the way, is one of my banes. It just hates me when I try to install that one. DBD MySQL, which is the DBI implementation for the MySQL driver. Yeah, it hates me. But you want to do this, because when modules go bad, things aren't good. Yes. So now that you understand TAP, you should probably understand that this test obviously failed. Test more. You can check out the documentation on MetaCPAN, just like any Perl module. It's a great place to search for things, check out the pod. It is kind of considered the standard test framework in Perl. You see this used a lot. Doesn't mean you can't use any of the ones I mentioned. Even make your own. There's a thing called, I'm not going into it too much, but there's a thing called Test Builder. The idea there is you can actually build something that's kind of test-friendly by using Test Builder and then using that as a framework to build your test whatever thing. So you can almost hook into like the TestMore suite, but you can create your own assertions, things like that.
I think TestMore uses Test Builder.
It does. Yeah, TestMore does use Test Builder. But what I'm saying is that you can use other things to do that too. TestMore is 14 years old, and it is very well maintained. In fact, right now, we're going through a big refactor. Its current maintainer, whose nickname is Exodus, Chad Granum, I hope I didn't slaughter his name, has been working on a refactor of TestMore, just cleaning out the guts, really trying to clean things up because it's been 14 years. Things need some improvement. And so he was hoping to get that out by 5.2.2. I don't think that's still happening now. He actually has a talk at YAPC about this too, which I am looking forward to going to and meeting him. And yeah, that's his blog. So you can even check out what he has been talking about. He is looking for help too, looking for people to pull in his new stuff, which he has like in a separate little disk somewhere. It's not actually out yet, of course. And then you can pull it down and start running your tests through it and making sure that everything's still working on your end for whatever module you're using. So here's a quick overview about TestMore. You're pulling it in. It's a standard Perl module. This is actually, you're saying, I want to test 4 of them. So this is called your plan. Then you've got your tests, which those of you that are familiar with TestMore will know that OK, require OK, is deeply. And this one are your 4 tests. These all do different things. This is a diagnosis message. This one could potentially be skipped, and then you're done. Now let's get into a little bit more about everything related to TestMore. So planning. I'd say a lot of people do it this way, starting with just, here's a number of tests you do. Trick is, what if you don't quite know how many tests you've got yet? Well, you can just use TestMore, and then when you're done testing, then pass in your tests. It can be a variable, of course. It doesn't need to be the actual number. So you can, counter something, tick it up as you're generating dynamic tests, pass it in when you're done, and you've got your plan still. Or maybe for some reason, this particular module, you just want to skip right now. Skip all the tests. Or maybe you still want to use a plan near the beginning, but you still want to do some sort of subroutine or some other sort of way of getting some dynamic number of tests. There's a plan function that'll let you also give out what you're planning. This is kind of important because you want your framework and ultimately your harness to know what the plan is, because they're going to spit out some useful information for you, like, I ran more tests than I should have. There might be something wrong. Or, I didn't run enough tests. What am I missing? You'll get, not necessarily in those words, but similar output through running your tests. And that can help you find problems with your particular module that you're working on, test module. Here's a bunch of data assertions. You've got the basic one, OK, which, as we saw, it's just true or false. Is and isn't is a little bit more complex. I've got a more detailed thing about how it uses and what kind of it spits out. We'll see that in a sec. But you're passing in something you got. You're passing what you expected. All of these, you can pass in the name, so you'll see that in your output. Like and unlike are cool because now you're doing your regex testing. So I just want to see if maybe this word or two is in here or not in here. Great when you're trying to grab out third-party API output through some test module, and then you just want to grab something out of this huge message. Compare OK, I like using this one a lot. So this one is so fine-grained, you pass in what you got, you pass in the operator that you want to use as the conditional, you pass in what you expect, and then your name. So 1 == 1, or 1 = 2 in case you want it to fail. But that's the concept. Or EQ if you're doing string testing. Very useful. If anything, I would also recommend using most of these and avoid OK, only because when you get error output, you get a lot more valuable information from those than you do from OK. When it's not OK, it's just not OK. When it's not OK, it tells you why it's not OK on those. And there's actually the example. That's not OK. You're not seeing any data, nothing. It's just not OK, which means you got to go dig through your test and find it. Or dig through your code. Or both. Here's is. I'm just showing you kind of the not OK examples. All of the OK examples pretty much say the same thing. OK, the test index, and your name, if you had one. Or if it let you have one. The not OK, there's the gotten expected. That's why these are great, because you're actually going to see values that you're getting. You're seeing your data as you're going through. So it's kind of cool because you're kind of debugging your output right there as you're running your tests. Same concept with like. Obviously, this one is a little bit more regex, so it's saying, it doesn't match right here. And there's actually, these are the tests I was doing. And then compare OK, same thing. Got what and then what I expected. Some more data assertions. You've got can, which is great for testing if a module can use a method. Pretty much it's going to run the universal can on it and then say, yep, it works, or nope, it doesn't, let me get anything back. ISA, you want to test if it really is this module that you're looking for. New OK, which is also kind of like an ISA. It does an ISA, and then it returns the object, which makes this very cool for instantiating your objects, and I don't use it enough. Use it more if you can, because it really is useful. You get an extra test out of it, and you get your object that you can then work with and do more tests with. And then also, just in case none of the assertions particularly are working for you, you can actually just send a pass or send a fail, just right out there. So maybe you're just doing some other really crazy testing. You get down to it. If it worked, pass. If it did else, fail. That simple. Some more detail. So this is what a can OK looks like when you fail. So like I was saying, it actually does run the can on the module. And by the way, that can be just the class name, the module, test module. It can also be an object, so you can just throw in the object in there and then do run can OK. It'll be able to tell the difference whether it's that object reference or not. There's is OK. So I actually went so far as to give it a name, so a cool module isn't cool module. I'm also just newing it up right in there. If you're doing is OK, you might want to new it up outside, especially if you're going to use it. And new OK, once again, works like is OK, has the same sort of output, just so you know. So there's pass and fail again. Pass, you just get it works. Fail, you get it failed. So once again, that'll work kind of like an OK, not OK situation.
Those are actually just wrappers for OK, but 0 and 1. So let me get it.
Right, so you can totally do that too. I actually like using the pass and fail.
Yeah, that's more clear though.
Yeah. So testing modules. This is another set of assertions. You have use OK, and you have require, pretty much. So the two ways that you pull in modules in your code, you're using them, use module, or require module. Now, with use, they also, notice this, they recommend you throw it in a begin block, because that way you also get your importation of symbols and everything happening at compile time. So if you're going to do use OK testing, throw it in begin block, because then you also have it, and then you can start doing other stuff with it. That's, once again, what happens when it fails. There's actually a lot more information, because usually it's going to spit out that long error message saying, I can't find this module in Inc. in any of these directories. I don't know what to do. So I just kind of truncated that. Require, same kind of concept, but obviously in require, you're not really worried about importing your symbols, so you're doing that later. You don't need to worry about putting in a begin block. So just require OK that module, Same kind of concept, same output. Data structures. So we're not just doing scalars here. We're not going to be just doing our comparisons, right? We need something to test our hashes or our hashes of arrays or our arrays or our hashes of our arrays, whatever we're doing, right? Well, testmore gives us isDeeply. So here's an example of a hash that has an ID, has an array. I pass it in here. Here's my hash. I pass in what I'm expecting as a test, and then check. There's an error.
Question.
Yeah.
Do you happen to know of a module that has a version of isDeeply where I can specify what portions of the structure I care about and what portions I don't?
Here, test deep.
Test
It's
deep.
awesome.
Perfect. Thanks.
Yes. In fact,
You were
oh,
talking about it?
I was just going to mention this.
Okay.
So there's two other modules out there, test deep and test differences, that also give you a lot more assertions in the testmore framework, and they can help you with testing other parts of your data structures. Another thing to know about the isDeeply from testmore is if you're doing if you have subroutine references, it doesn't really like it yet. So that's another reason you look at test deep or test differences, because sometimes you're going to be popping in those subroutine references, and then your code might just spew on you. Diagnostic messages. These are fantastic, of course. You don't necessarily have to do a data dumper or print or warn or anything or die. You can just diag, and then when you run your test, it comes out as a comment. So pound, space, whatever I'm saying. Notes are kind of interesting. So understanding that tap is in your tests and that it goes to your test harness, and then your test harness does output, then this one becomes a lot more relevant to you, because let's say you want something that comes out in your tap for your test module, but not necessarily gets out to your harness. So you can actually even do debugging on your test modules and then run them directly and get that output, but you won't get that output when you run prove. Very cool. And explain, which is another way of doing the data dumper type thing. So you hit explain on the variable, and then you get your output in a diagnostic type form. Very, very handy. I don't do that enough either. I usually use a debug from some other way. Yeah. I should use that more. You should use that more too.
Explain it's actually using data dumper, so if you're doing use data dumper,
Yeah.
dump.
Yeah.
Use
Same concept. Use explain. Okay, so conditional tests. Skip and to do. This is for when if you're TDing, you probably won't do this as much because you're not trying to skip. I mean, you could be skipping stuff, but you might not to do anything. So skipping is great for let's say you're for some reason relying on a third-party API in your testing modules, which is kind of crazy, but maybe you're doing it. If you can't get anything back, because maybe that's the primary reason you're doing it. I mean, and there's another good use case. If you're in a CPAN module, so you're creating your own CPAN module, and you're going to use something a little bit more non-standard and third-party for your test modules, then you can wrap all of that in a skip. Say, if you're there, I'll run you. If you're not there, I won't. This is actually great for pod coverage. In fact, I'm doing this.
Yeah, pod coverage or test Perl critic.
Yeah, Perl critic is another good one.
You might be interested, but your consumers are not necessarily.
Exactly. So yeah, skipping, you're going to pass a message, the number of tests you're going to run. So you've got a mini plan here, and then your condition, and then the list of tests, all within your block. To do, same kind of concept, but this is one, I haven't done my test yet, so here it is. So once again, if you're doing TDD, you probably won't do this so much, unless, of course, you want to write something down and commit before the end of the day on Friday, because you won't remember it on Monday. Last little thing here, bailing out. So this is just a big, something really bad happened, get me out of my testing. I need you to know there's a bad thing happening. We can't continue. Don't go any further. Here's the message. Oh, and it started working. Sorry. Yeah. So bailout, very handy. Small detour. I actually was requested to put this in here, and the guy's not here. But if you're mocking objects, this, by the way, is another way you can handle testing things that you don't necessarily want to, maybe you're doing some third-party API, or maybe you're pulling in some sort of service that might not work in your alpha environment per se. Mock Quick is one of those great ones that you can use to help with this. I'm not going to go into too much, but I just want to show you, here's how you can mock out a class. There's other options, so go check out Mock Quick. And essentially, I'm making a quick class. I'm creating it as that class. Oh, by the way, don't use a class that you want to mock. Mock it first, and then later you can actually let it go and then use the real thing if you want. But make sure it's not in there in your module first. Then I want a new function. I'm subclassing on multiple modules. You can subclass on one also, just pass in the string instead of an array ref. Here's some attributes. Simple method that returns a simple value, maybe a more complex method. And then it's like it's in your namespace, so you can actually new one up, and then you can, of course, run all the methods that you created. And if later, for some reason, you need to, you can even override your methods to be doing something different and even restore them to the previous version. Very handy stuff. And then at the end, undefined, that's how you pull it out. So it'll remove it, and then you can actually use the real thing to do other stuff. That's one part of Mock Quick. There's, like I said, more. I highly recommend that you check that out. Very useful tool. And I'm running close on time, but I think we're close. Another thing I wanted to bring up, not only just testing, but how much are you testing? We have Devel Cover. This is a pretty cool tool to come back and kind of give you a grade on how much coverage you're testing on your modules, your scripts, etc. It's not bulletproof, but it can give you some good ideas and gives you lots of data, which is fantastic. There's the meta CPAN for it. Like I said, gives you coverage information. Very friendly, of course, with our .t tests. There's actually a command to run. I actually pop that in a shell script, and then I just run bin cover.sh, and then it'll start spitting summaries for me, because I like watching summaries occasionally. Another cool thing about it, which I'm not going to show you yet, is that you can do. So there's a test summary. You'll actually get an HTML doc built probably where you run it, I'm pretty sure, unless you specify otherwise. And it will go line by line in the code you're testing, and then tell you where each one of these types of coverage variables failed or succeeded. Statements, branches, conditions, subroutines, pod if you're doing it, and then kind of the overall time it's spent in checking coverage on your modules. And so then these are percentage values, so you're kind of getting your percentages, and then overall, then there's like your grade right there. That, by the way, is a module that I recently did. I was kind of happy with 86. I wasn't expecting it.
You could do better.
I could do better. I could totally do better. So let's apply what we've learned a little bit. Let's say you're using an existing code base. What are you going to do? Well, depending on whether you're with a team or by yourself, it's a good idea to have some best practices, these, others, and procedures figured out. How are you going to set up, what's your test framework going to look like? How are you going to do your testing? Are you going to be behavior driven? If so, you actually have a lot more work to do because you need to talk about the process of design as well. Or are you just doing your own thing? Fine, whatever. But figure it out and then stick to it. Be self-disciplined. If you're going to do test first, be test first as much as you can. It's not the easiest thing to get in the practice of doing. And sometimes you just want to get in there and code something. So I get it. Once again, it's a methodology. So, if you don't do it, it's okay. Forgive yourself. Move on. Also, when you're doing an existing code base, you probably want to ease into it. We have a few code bases at Bluehost that aren't as tested as they should be, and we're working on it. So what we're doing is creating tests for all new features, and then every time we have an opportunity to do refactor, maintenance, bugs, start throwing in some tests. Get there. Any testing is better than no testing. If you're creating a new database, things are a little bit better because, once again, like I said, still have your best practices and procedures. Very important. Make sure everyone agrees to it. Everyone's on the same page. When you're getting in there and you're doing your stuff, you want to also be able to rely on everyone else, and they want to be able to rely on you. So best practices and procedures, I can't stress that enough. You're free to do things right on a new code base, obviously. So, hey, if you want to do TDD, great. Start doing TDD and continue all the way through, and then by the time you're done, you have a full suite of regression tests, and you're maintaining your code base. So 2 years down the road, you're still cool. And then, once again, you can really win with a test first, because you could go into your code base and say, oh, I want to just spit out this framework. I'll come back to the testing later. That's not going to happen. I'm sorry. 99.9% of the time, you're actually going to be going on and doing something else later, or you've got a time crunch or something. You're not going to be doing your tests. So that's why another reason to do tests first. You've got them. You don't need to worry about it anymore. It takes a little bit more time, but you'll get better at it as you get practice. And with that, I kind of want to talk about something else. So this is a little bit of a deviation. But about 6 or so months back, or mostly last year actually, I had this cool idea. I'm a kind of a Lego nut. My kid's a Lego nut. We love Legos. I went to Legoland last year. I go to Lego events. Salt Lake City Comic-Con was awesome for its Lego displays. That's actually where I saw this. And that was kind of part of my idea. So I thought it'd be really cool if I could write some code that made me one of those. But then there was this talk at Openwest that I kind of wanted to do. I wanted to start talking about all the test-driven stuff we were doing, all the fun stuff I'm learning about Test More and its friends. Why not do both? And so I did. And that's why I built this. So on CPAN, as of this week, I built this fun little module. And this actually will take a PNG file, pixelized, and convert it into a series of Lego instructions, which you can then build one of those Lego pictures from. Now, the knobs are actually up on mine, and I'm working on the knob-facing version. So very, very much so a prototype. What?
An example from this?
I do have an example, and I wish I had something to show, because I have a good story about that. I'll tell you that real quick in a sec. Let me tell you the testing side of things, because this was totally about my project. So I built 8 separate test modules for this, 116 test cases by the time I was done. My average score, you saw earlier, only about 80% of it was implemented test first. I was really trying to be 100%, but I got into this one little phase where I oh man, I need to refactor all this code. And I started writing the code. I'm like, oh crap, what am I doing? And then I went back and then I, put all the tests in, and then I felt bad, and then I started doing test first again. Another thing that I did is I used a lot of behavioral terminology. I really like this from BDD. There's this idea of given, when, should. Given this situation, when doing this, it should return this. So for all of my test modules, I would say given, well, I actually didn't use given so much. I would just actually do when. So earlier you saw like a when viewing JSON. That's my when part. All my modules are the whens. And then I created a series of subroutines in them, and those were the shoulds. Should do this, this, and this. And then each of my subroutines ran through the assertions it needed to facilitate that behavior. It actually made for a great design-first sort of methodology. That's actually the picture that I used for my test run, which you might saw was my avatar picture from the beginning with a little bit of modification. I got rid of all the navies. And now I actually want to show you the test coverage. So this was the other HTML doc I was talking about. It'll start out with this. There's your overall again. And then you can drill down into a module. And I'm looking at my code now, and it's telling me on each one of those areas where I'm doing good and where I'm doing not so good. And so this is actually a great way, if you want to have coverage back you up, to go in and then say, oh, I missed something here. Takes a little bit of time to translate, depending on what you're doing. But then I can go back and start writing more tests that'll hopefully cover those other cases, whether it's a branch or conditional. And there you go. And I need to get out of.
I found sometimes that as I look at the test coverage charts and I start thinking, well, how can I test this condition? I sometimes will find, oh, that's unreachable code. You know, and you'll realize it.
There is cases where there's unreachable code. And test coverage actually talks about some of those. And then this is the output. I apologize once again. I wish I could have actually brought the example here. So Pick-a-Brick is the Lego store area where you can actually purchase individual bricks. Turns out that they don't have everything there. So the first version of my conversion just said any of the basic Lego colors. That didn't work because Pick-a-Brick didn't have them. So then I had to build whitelisting into my module. So then I could say only these set of bricks. So I did that. Took a little bit longer, and then I ordered it as soon as I got it working. So this thing is actually on order from, where is it, Denmark? Is that where they send it to me from? It's been 2 weeks. I was really hoping I had it for today so I can build it real quickly and then show it to you guys. I will have it, though, by YAPC, which this talk will be at. So even if you don't come to the talk, please come to YAPC, and I'll show it to you. But besides just giving me the list of bricks so you have your shopping list, you also have your instructions. So one thing I kind of did here is the little alts will actually tell you what sort of dimensions your bricks are, and then there you go. There's some still quirks about it, like for instance, you may notice that there's a lot of bricks that are going straight in a row. That's not a very good structural integrity way of building a Lego. So there's some cool problems that I still have ahead of me to play with this code. But the fact is, I was able to take that list, and I did. I spent about an hour on Pick-a-Brick one night and went through and purchased this. This, by the way, cost me about $100. So, but highly worth it in my opinion. It's going to be a lot of fun when I actually start using pictures that I want instead of just test pictures. Thank you very much for coming. I really appreciate your time.